Hey guys, today we're going to talk about factoring and specifically a new pattern that we're going to be looking for, a quadratic trinomial. Now the one that we're going to look at now is going to be of this form. We say ax squared plus bx plus c, where a, b, and c are all integer coefficients or an integer constant. And the first one we're going to look at is when your a is equal to 1. So essentially this form is just like x squared plus bx plus c because you have a coefficient of 1 here. So we're going to look at this particular form first. And we'll start off with an example. X squared plus 6x plus 8. Now to factor, you're trying to find out what was multiplied together to get here. In our last video we talked about looking for a GCF. But if you look for a GCF here, you're going to notice between the three terms, there is no GCF. So it kind of seems like this polynomial is prime. We can't factor anything out. But this is going to be our first pattern we look for. So in a trinomial like this, in the form x squared plus bx plus c, b is 6 here, c is 8, and your a is 1, this is actually going to factor in a way that we could have FOILed something to get here. Meaning we could have multiplied two binomials together to get here. Now the first thing you would do when you multiply binomials is you multiply the first two terms. So think of what two terms you'd multiply together, what times what would equal x squared, and hopefully we arrive at some point, x times x would give us x squared. And now if we were to go through the rest of FOILing, you would do first, then you would do outer. So you would do x times something, some number over here. Then you would do inner, you would do x times another number. And then you would have the last. The last would just be your constant times your constant. So I'm going to focus on that right now. What times what would equal 8? We have some options. You could do maybe 8 and 1. You could say plus and plus. 8 times 1, if you FOIL this, x times x is x squared. You're going to do x times 1 is x. X times 8 is 8x. So you're going to end up with 9x, which isn't what we need, but your constant would be correct. So we're close, but not quite there. So let's think of some other numbers, or other factors of 8 that would work here. Well, 8 times 1 doesn't work. How about 2 times 4? Do x times x, you get x squared. X times 4, you get 4x. 2 times x, you get 2x. And 2 times 4, you would get 8. Notice how we will simplify to this. So the factored form is going to be x plus 2 times the binomial x plus 4. This is our first pattern we look for. So if we have a trinomial with a coefficient of 1, then there's a special relationship here that we're going to see if we can recognize in future ones. Now the form is, right here, x squared plus bx plus c. If we're in this form, a quadratic trinomial, to factor, it's going to end up being two binomials. So x squared, so it's going to be x times x. And I think in the example here we have plus m and plus p in the binomials. Now this m and p, they're not really going to show up a lot because they're going to be numbers that you put in here. But your m and p need to multiply together m times p to equal c. So you're going to look for two numbers that multiply together to equal c. N times p is equal to c. And they also need to meet the requirement that when you add them together, they're going to equal b. M plus p should equal b. Because when we FOIL this, x squared plus, I'll write it like this, plus px plus mx plus, well, p times m. So you're going to end up adding and combining those two terms together to get your b. So the p plus the m is going to have to equal the b. So when we do problems like this, and I'll go back to that last example we did, your thought process when we recognize this pattern, this is just one pattern, is what factors of 8 add up to 6? Because that's what's going to make up your binomial. And there's going to be different combinations of factors, like 8 and 1, that's two factors of 8, but they don't add up to 6. 4 and 2 is the correct pair here. And when we do our next example, I'll show you a nice way, if you're having trouble, to set things up, a little table you can make. So our next example, we have m squared plus 9m plus 20. Now from what we just did, you might recognize really quickly what the answer is. Notice we are a trinomial, quadratic trinomial. Leading coefficient is 1, so we're in the correct pattern here. You got to make sure you're in the right pattern, the right form. So we're going to be in a binomial. To get your m squared, you're going to have m times m. Now for these constants here, you're going to be thinking, what factors of 20 add up to 9? You might notice it really quickly, you might not, just by the off chance that you don't notice it really quickly, or in the future if you don't notice it really quickly, what you can do is, well, our c is equal to 20, so our c equals 20. So we need factors that multiply to be 20, and our b equals 9. So I would just list factors. 1 times 20, that equals 20. When you add them together, well, that's 21, so that one doesn't work. Your next one, your next pair, 2 times 10, that equals 20. When you add them together, it's 12. That doesn't work. Going 3 times, well, there's nothing times 3 that equals 20, so let's jump to 4. 4 times 5 equals 20. When you add them together, it's 9. You got the 20, you got the 9. This is our winner right here. So our m and p for this are going to be 4 and 5. So plus 4 plus 5. Notice when you were to FOIL this, you get m squared plus 5m plus 4m, which is 9m, plus 20. So this is the factored version of m squared plus 9m plus 20. Here's our factored form. We have 2 binomials now. I'm going to try a few more, and then we'll see other cases in the future. So our next one, we have x squared plus 8x plus 15. And I'm going to make this little table here. As you get better with these, you don't need to make the table, but just because it's new to us. Our c is 15, our b is 8, and the ones we're working with now, we're always going to have an a of 1. If you don't have an a of 1, things change a little bit. So notice that we are in the correct form. We are a quadratic trinomial. And let's go ahead and x and x. So again, our b is 8, our c is 15. What times what is 15? Well, 1 times 15 is 15. You add them together, they equal 16, not 8. So 2 doesn't work. We have 3 times 5 is 15. You add them together, you equal 8. There's our winner. So you're going to have 3 and 5. Here's your factored form, and we're all done. If you were to FOIL this out, you would end up with this trinomial right here. You can try these 2 on your own, and we'll check here, and then I'll show you one other problem. It's a little bit of a challenge and what you can do. So, this guy went away. So let's go ahead and do the first one. D squared plus 11d plus 24, and check to see that we're in the right form. We recognize this pattern. Leading coefficient of 1, we're a trinomial, and we have d squared. This is like your bx, but it's bd here, and then plus your c. So let's go ahead and make a little table here. We have c is 24, b equals 11. In our factored form, we're going to have d times d to get your d squared. Now your c was 24, so let's do 1 times 24, that equals 25. Doesn't work. 2 times 12 equals 24, that adds up to be 14. It doesn't work. 3 times 8 is 24, that adds up to be 11. So you're going to multiply 3 and 8, that'll get you 24, and you're going to add up to be 11. When you were to FOIL this out, you would end up with 11d. So there's your factored form. And your next one is a nice y over here. So we have y squared plus 16y plus 48. And notice you're in the right form. Leading coefficient of 1, trinomial, y squared, y, and a constant. So b equals 16, c equals 48. Let's see, 1 times 48, well, that's 49, that doesn't work. 2 times 24 will get you 48. You add those together, that would be 26, doesn't equal 16. Still no luck. 3 times 16 will get you 48. You add those together, get 19. That doesn't work. Let's go to 4. 4 times 12, well, that equals 48. When you add them together, you get 16. There's your winner. So in our factored form, we're going to have the two binomials with y's. We're going to have plus and plus, and it's going to be 4 and 12. You also may notice on all the examples we've done, it's been a is 1, as we said it was going to be, and we've had addition signs for both. Those don't have to be addition signs. You could be subtracting. It'll change your signs in here a little bit, but we're focusing on just using positive numbers for now because this can be kind of a hard topic to understand at first. We're going to do one more. We'll combine a couple types of factoring together, and then you can go ahead and practice some of these. So our next one, and this is how we'll see how we can combine different methods of factoring. So check to see if you're in a certain form. Again, we're looking for patterns right in the beginning because there's going to be different patterns that tell us different things. So right in the beginning, you might notice we're not in the right pattern. We do have x squared, we do have x and a constant here, but your a is 2, b is 12, c is 16. But if we think back to what we did in the last video, first thing you should always look for is a GCF. So if you look at these, they all have a 2 in common. So you can factor out a 2. So 2 comes out, and you're left with this right here. X squared, or 2 times x squared plus 6x plus 8. And that's actually very similar to our first example because that is our first example that we did. So you can have 2 times the quantity, and then you're looking for 2 things that multiply to be 8, your factors of 8 that add up to 6. And if we remember, or if we just refigured it out, it should be 2 and 4. So this would be the factored version here in our factored form. Alright guys, that's all we have for today. In our next video, we'll talk about what happens if these aren't both addition signs, how that changes things a little bit, and we'll start working into pulling the GCF out first and then recognizing this pattern. This is just a new pattern that we will recognize and know that we can factor it into 2 binomials. Have a good day, people.